All right, let's begin. Did you just turn in homework 3? Okay, good. Homework 4 is available now. It's 9 problems. It's due next Wednesday. And we're going to follow the same approach where I'll try to introduce most of the ideas on that assignment in class through an in-class exercise. And so it'll be very uncommon this semester that I just throw you straight to the wolves and ask you to figure something out on your own. More typically, there will be an in-class exercise problem that the key ideas, the nugget of the concept is in that. And sometimes it's just a matter of applying the exact same process but to a different problem statement. So if something looks a little bit unfamiliar when you're working on the homework, my recommendation is look back through the last few in-class exercises and try and see, is this just like something that we've done before? Because most of the time the answer is going to be yes. But with that said, I would love to have you come by my office during office hours. I get awfully lonely during my office hours. It's quiet in there. It's like a ghost town. Nobody comes to visit me. Nobody asks questions about engineering economy. And frankly, I'm a little insulted. You know, like if you'd show a little more interest in the class, it'd make me a lot happier. So come, ask questions if you've got them. You can call me on Teams. I want to be helpful because I want you to learn this material. It's really important. If you do well in this class, some of the skills you're going to learn can carry you through in unexpected ways, especially the Excel proficiency. If you've never used Excel before, or even if you have, you're going to develop a lot more skill with that, and it can be used in lots of ways. So you're going to be kind of an Excel wizard by the end of the semester, and I hope you find that useful. So homework 4 is available. It's due next Wednesday by noon. And today we're going to be talking about the least common multiple approach. It is a tool that we use to compare alternatives. So before we get into that, let's just recap some of what we've been discussing so far. We started the semester by talking about interest and interest rates. And who can refresh our memory on why lenders demand interest when they loan money? What are some of the reasons? Yeah. Risk. What kind of risk is? They face multiple risks. Do you remember one in particular?
That they might not get paid back.
The default risk. They may not get their money back. What's another risk that a lender faces when they loan money?
They won't get the equivalent value back.
They wouldn't get the equivalent value back. Yes. And the specific way that that would happen is if it's called interest rate risk. If they loan out money at 5% and then suddenly inflation goes crazy and the very next day they could have gotten 10% on the loan, then they're really losing out. So it's separate. You'll still make your payments to them as agreed, but the money they're getting back isn't as valuable as they thought it would be when they first made the loan. That's interest rate risk, when the prevailing interest rates in the economy suddenly change. The risk to the lender is that the interest rates would go up after they made the loan. So that's interest rate risk. So risk is one reason why lenders demand interest. What's another reason?
Future money is less valuable than present money.
Very good, because the money they're going to get back is less valuable. So if a lender gives you $5,000 and you give them back $5,000 in the future, you're paying them back with dollars that can't buy as many things, because in the future, prices will be higher. So it's because of the time value of money that lenders demand interest. So we talked about that in the first week. Economic equivalence is the idea that we can take into account the changing value of money over time and translate present values into an annual series or into future values that, even though the number of dollars aren't the same, their economic equivalence can be determined because we're finding out a similar purchasing power in the future. So economic equivalence we talked about, and compounding is when money moves forward in time into the future. The amounts get bigger because of the time value of money. Discounting is when we're finding the present value of amounts that are in the future. We're moving it backwards in time. So these compounding and discounting verbs has to do with what direction we're moving the money through time. You learned the PV function, the FV function. All right. We sketched it out with cash flow diagrams, translated those into cash flow tables. But this is just teaching you some concepts and tools that are necessary for you to get to really the heart of the course. I mean, the course is about money, but really what the course is about is decision making, because you're not going to be an accountant. So you're not learning about the money just for the sake of keeping track of the money. But you need to understand money in order to make reasonable decisions. Engineering decisions that have to do with purchasing equipment, decisions on how to price your services or your products when they're going to be paid for in the future. So we're learning about money simply because money is a tool that we use during decision making. So decision making is the heart of the course. If somebody asks you what engineering economy is about, you can tell them it's about money, but really it's about making decisions and learning different analytical procedures to make smart decisions so that you maximize your profit, minimize your costs, so that you're acting as a responsible representative for your clients. So comparing alternatives is what we do when we have multiple choices for equipment that we could buy or multiple options for investments that we can make. And that'll be true most of the time. Most of the time, if you're buying a computer or a machine or whatever, there's usually substitutions and options. So do you want to have a robotic assembly line where there are relatively few people involved in making a car? Or do you want to have more of the human touch in making your cars? And there are some things that only the robots can do, some things that only the humans can do, but on some tasks they may be interchangeable, and we have to have the tools available to understand how to make the decision. Because, for example, in this specific case of the robots and vehicles, the robots are more of a one-time cost. You buy it up front, and then you've got a minimal electrical expense. Maybe you have to calibrate and maintain the equipment over time, but it's a lump sum present outflow, whereas human labor is a recurring annual expense. So we can just think about this as maybe is a present value outflow, whereas this is an annual series outflow in the case of human labor. So which is going to give you more profits if you're in management and you're trying to decide for planning purposes whether you should go with robotic machinery or humans? So we're going to learn a lot of tools through the semester on comparing different options. And one of the challenges we'll face when we do that, like one of the problems that we have to somehow figure out how to get past, is that sometimes the two options have different time frames. So let's talk about some terminology, and then we'll get to that core issue we're going to address today, is the difference in timeline. So a mutually exclusive alternative is what we use to describe when you're only going to choose one option. You wouldn't do the robots and the humans. You're going to do one or the other. So that means that these two options are mutually exclusive. Sometimes, though, we may have independent projects. In cases like that, what it means is you can select more than one option. So if you have, for example, $10,000 that you're investing, you don't have to put all $10,000 into a savings deposit box or into a checking account or buying stock. You could split it up and do different things with different amounts. And the same may be true in business as well. There may be certain times where if you're getting asphalt rolling equipment, maybe you'd get one big one and one small one, so that on the big jobs you use the big asphalt roller, on the small jobs you use the small one. So there are instances where you can select more than one alternative. So we're just learning the terminology so that we can describe certain situations and understand them. when you're analyzing your options, you should always keep in mind that doing nothing is a viable alternative. And frankly, most of the time, doing nothing is the best alternative. Usually, like in a world of unlimited ideas, the best idea is none of them. So keep that in mind, that if you're comparing alternatives, you should also look at, well, what if I didn't buy that thing? Then what would the situation be like? You have to analyze it as a possibility at the very least. Revenue-based projects are when what you are buying will generate future money that's coming to you. So it's a project that will return a profit, we hoped. But there are some alternatives that are cost-based projects, and so those kind of alternatives may only have outflows. So it may be that, for example, you have to put a roof on your house. You can get a metal roof or an asphalt roof. Either way, that new roof is not going to generate income for you, but you have to have it. Otherwise, all your stuff's going to get wet. So that would be an example of a cost-based project, is it only has outflows and there's either the same revenue or no revenue. Any questions about this terminology so far? All right, present worth analysis. Analysis means we are trying to make a decision on how to proceed. That is why we would analyze something. You don't analyze it unless you have a choice to make. And so if we are making a decision, we have to know what are the rules to choose option A or option B. I'm going to call that throughout the semester decision criteria. And what you should always do on a homework assignment or on an exam is if you recommend a certain outcome, like choose alternative A, you have to support your recommendation by referring to the decision criteria. So you have to say why. Why choose option A? So the present worth analysis method is if we have two different choices, take everything to the present. If you have alternatives that over time have inflows and outflows, to compare them, all of the money has to be at the same time frame. So for two alternatives or multiple alternatives, discount everything to the present using the minimum attractive rate of return. That just means the interest rate. If you are a company, there's a certain interest rate that your company insists on making, or I guess we could call it a rate of return. If your company is looking to generate profits, it may be that they don't want to do a project unless it has a rate of return of at least 5%. And the rate of return that they want is largely influenced by their borrowing costs. Like you wouldn't want to borrow money from the bank if it costs you 8% to borrow the money, and then turn around and do a project that's only returning a yield of 6%, because then you would be paying the bank 8%, earning 6%, and you're falling behind. So the minimum attractive rate of return is just what is the lowest interest rate that your company is willing to accept for projects. So the procedure here is discount the cash flow to the present. And you've done that before. You've done it by hand. You've done it with Excel. Take all of the future amounts to the present for both alternatives. And if the projects are mutually exclusive, meaning that you're only choosing one option of the two, then the decision criteria is select the project with the highest positive present worth. So what does that mean in real terms? It means choose the project that's most profitable. I mean, that's obvious, right? You want to maximize your profit. But we have to be formal about it. We have to give all of these things labels. The decision criteria is, if you can only choose one option, select the project which has the highest positive present worth. If the projects are independent, meaning that you can choose multiple alternatives, then you'd select every option that had a present worth of greater than or equal to 0 when you're discounting the future values at the minimum attractive rate of return. What do you think you'd do, in this first one here? It says, select the project with the highest positive present worth. What does it mean if you have a negative present worth? Yeah. It means in debt, or it means there was more outflow than inflow. So you wouldn't want to do a project like that. If you had to invest $50,000 now, and then you have this series of revenue over time coming to you, discounted to the present, and what if the present value of all of your future profits, if you found out the present equivalent of that, what if it was only $45,000? Should you do the project? Absolutely not. If it costs you 50 and you only get back 45, you'd be losing money. So this rule here, the decision criteria, says it's not just the project with the highest present worth, it's the highest positive present worth. Because if both of your options have a negative present worth, then that means go for the do nothing option. Remember, do nothing is always an alternative. So I may try and trick you at some point. I'll say, choose option A or option B. And maybe when I'm trying to trick you, I'll make both of them negative present worth. And then you'll have to say, it's a trap. You have to say, choose none of them. All right? So remember, the do nothing alternative is always available. Okay, so here's the problem though. Sometimes our two options will have a different time frame. Let's say that option A is to buy some equipment that costs $11,500. So it's a cheap piece of equipment that only is going to last for 6 years. So option A, we're buying some equipment that lasts for 6 years, and then during each of those 6 years, we get profits of $5,000. So if we choose option A, this is what's going to happen. And then at the end of the 6 years, it looks like we just roll that equipment into the river. It has no salvage value. So the only money we're going to get is our profits over time. Option B, how is it different? Well, it costs more, and it doesn't yield as much money, but it lasts longer. So this is a problem. We can't, without doing something, we can't compare these two because they have a different useful life. You can't just compare them directly as is. So the present worth analysis would say, let's find the present value of option A, let's find the present value of option B, and then the decision criteria for the present worth analysis says, choose the option with the highest positive present worth. But we can't apply it until they cover the same study period. The study period is how many years the equipment is in operation. Option A goes for 6 years, option B goes for 9 years. So we can't compare them unless we do something to make the study period the same. So LCM, which is the topic of today's class, least common multiple. It's a method that says, well, what we could do to make the study periods the same is we could just buy option A 2 more times, and then it would cover an 18-year period. And then we could repeat option B twice, and it would cover an 18-year period. And then the study period for both alternatives is the same. So least common multiple is, it says repeat the cash flow as many times as you need for the cash flows to terminate at the same year. So this is the LCM method, is just repeat it. So look at the cycles. Option A is buy the item in year 0 and get revenue in year 1. What I'm saying is if we apply LCM, we're going to buy the item again in year 6 so that it's available continuously. Because in option A, at the end of year 6, we roll the equipment into the river and we no longer have equipment anymore. We want to have 18 years of uninterrupted service with the equipment. So we have to buy the item at year 6 for it to be available from 6 to 7. So look at, if I repeat it, when I'm repeating it. So I'm buying it at 6 and 12, and then there's a continuous stream of uninterrupted revenue reflecting the fact that the equipment is in service continually for an 18-year study period. And the same thing is true for option B. We bought the item in the last year, at the end of the last year, so that option B is in use the whole time. LCM. It seems like students sometimes are tempted to buy the item one last time. Sometimes, like the mistake that I see pretty often, I'm going to tell you the common favorites mistakes, like the greatest hits, so that you'll avoid them. Sometimes people just get a little bit arrow happy. They'll put one more arrow at the end, like at year 18. That's not right, because if you bought the item again at year 18, then that means you're going to have a bunch more revenue after that. So we want it to stop at 18. So don't buy it again in the last year, because you don't need it after year 18. And the other mistake is sometimes people would repeat the cash flow diagram by buying the item at 7. If you buy it at 7, then you don't get revenue until 8. So it would leave a gap, because when we buy it at 0, we have revenue at 1. So be sure that you buy it at the correct time and not in the terminal year. So now we could compare these alternatives. We could compare them because they cover the same number of years. If they cover a different number of years, we can't yet compare them. We have to do something so that they have the same study period, the same time frame for our analysis. So there are some assumptions that are built into this method. Like what I've just suggested you could do, it assumes that you can buy the item again. So it's not like it's a once-in-a-lifetime purchase. I'm assuming that you could buy it in the future, and here I'm assuming it's going to cost the same amount. That may or may not be true. Like if it is truly a unique item and there's no substitutes, then you may not be able to use the LCM method. Or we may have to adjust if it's going to be more expensive in the future. So you might have to say, well, it's $11,500 the first time, and then it's going to be $12,000, and then $12,500. So the default assumption is that we're going to be able to purchase it at the same cost in the future. But ask yourself whether that's true. And if not, then you'll have to adjust. For some things, equipment is relatively constant over time and may even be cheaper. Like computers that have the same capability get cheaper over time. So you wouldn't be in trouble if you made the LCM assumption for computer equipment when you're looking for it to have the same capabilities over time. If it can't be purchased for the same cost in the future, then you could put in the new cost or apply other methods. We're going to talk about 3 different methods. LCM is just one of them. The other 2 we'll talk about in class on Friday. Today we're focusing on least common multiple. The other thing you need to ask is, will the revenues be the same? Because what we've done here is just said, just take the first cycle and repeat it without any adjustments. Are your revenues going to be the same over time? That may or may not be what actually happens. And if not, then you need to adjust your assumptions. All right, let me hand out our in-class exercise. Let's see. I'm going to ask you to do this one. Use it by hand. Problem 1, you need to do by hand. And then the second one, you can either do by hand or with the computer. Just to verify, for this first one, since both of the options last for 8 years, you don't have to repeat them. It's on the second problem that you're going to need to repeat the cycles. So for these cash flow diagrams, it's okay if you want to draw separately the maintenance charges and the fuel cost and the revenue. Like you can depict all of those, but what I did in calculating the net amount was simplify the cash flow diagram to look like what I'm going to need in order to calculate the present. Like it's simplest to just find P given A a single time rather than find P given A for each of these 3 annual amounts. The maintenance charges, the fuel costs, and the revenue. So it's a matter of preference. The way that I depicted it here was a single net annual amount and then that lump sum future value as a standalone F in year 8. I'll leave this up on the screen for a few minutes in case you want to check what you did. Basically what I'm showing is the sum of the present worths is the initial cost plus the present value of the net revenue and then the present value of that single lump sum salvage value. So 43,000 times whatever the factor is for find P given A at 10%, n equals 8. So in parentheses I've used that kind of language we employ in order to describe the problem statement type. And then the value for that factor after I look it up off the 10% table is here in parentheses below it. So we're using the present worth analysis to compare these 2 alternatives. In this problem, both alternatives have a useful life of 8 years, and so we don't have to do anything to adjust the study period. But we do want to identify which alternative has the highest positive present worth. Option A, Mitsubishi, has a present worth of $5,058. The Hyundai has a negative present worth. And so we would reject that alternative. It would be better to do nothing than to purchase the Hyundai in this case. But the Mitsubishi here is the better alternative. So if I scroll down a little bit further, you'll notice I put a statement at the bottom. The best alternative is Hyundai. Hold on a second. Mitsubishi. Why did I say it has the higher I don't know what I was thinking. I've crossed that out on my printed one. But the best alternative Mitsubishi since it has the higher present worth. The point is you should put a statement below that's interpreting the results as well. Any questions on this first one? All right. So here's the second one. So least common multiple. I already showed you this cash flow diagram earlier, but I want you to get the practice of sketching in on the paper where those subsequent purchases should go. Just so you get the reps here, so that you get the practice of applying the least common multiple approach. So even if you don't get through doing all of the calculations by the end of the class period, sketch what the cash flow diagram would look like if you do the LCM approach, and then begin the calculations in a way that looks similar to what I did here. You know, these calculations where We have the amount that's already at the present, the annual series multiplied by some factor, the future value multiplied by some factor. Okay, let me just walk you through what the solution should look like on this second one. You may need to go back through the video if you want to capture all the calculations, but you purchase the item again in year 6 and year 12. You don't purchase it again in year 18 for option A. Option B, purchase it again in year 9. And doing that allows us to have a continuous stream of revenue through the 18-year study period. So then what do the calculations look like? For option A, we've got the amount that's at the present, $11,500 is an outflow. Then we find the present worth of the $5,000 annual revenue. So find P given A for 4% and N equals 18. That's going to discount the annual series to the present. And then we have to subtract out the 2 purchases of the equipment. So here's the $11,500 purchase in year 6, where we're finding the present value of that, and then finding the present value of the second purchase of the item in year 12. So you'll see this first row is just kind of like the solution strategy, where then below it we start looking up the factor values for each of the P/A or P/F. Then below that is the result of the calculations, and finally the resulting value. So our decision criteria says to select the option with the highest positive present worth when items are discounted at the MAR. Anybody remember what MAR stands for? M-A-R-R?
Minimum attractive rate of return.
Good. Minimum attractive rate of return. It's a policy decision that's set by the company on how low of a project they're willing to accept. So at the bottom we state the result of our decision criteria. Option A has the higher present worth of the 2 alternatives. It is the one that should be selected. So your next homework is on Blackboard. There's a problem very similar to this. If you want to get started on it, that'd be great, while it's still fresh in your mind. So I'll see you in class on Friday, and we'll talk about the other 2 methods we use to overcome different study periods.